Good morning and welcome back. In today's lesson, we're going to take a look at solving a system of equations using substitution. Now, substitution is one of the algebraic methods that you'll learn. We will be looking at another one in a day or two, but this one works particularly well if you have a simple equation where one of the variables has a coefficient of 1. In other words, like this one here. I don't even know if you can see that. Now you can see it. This one here has a y variable which has a coefficient of 1. Okay? Now, in another video where we looked at the solutions to your practice problems for section 8.2, we've already gone over this, but I'll go over it again quickly. Today's lesson will mostly, though, be focused on solving word problems, which kind of adds another layer of difficult to this concept. But anyways, solving a linear system using substitution, these are the steps you go through. The first thing you want to do is you want to choose the simpler of your two equations and isolate the variable that's easiest to isolate. And generally that's the one that with a coefficient of 1. Take that value that you found for your isolated variable and substitute it into your other equation. That results in an equation having only one variable, which can then be isolated and a value can be found. And then finally, that value is substituted into either equation and you get your solution. Now, in words, it may sound kind of confusing, but you have the steps here. You have the steps that I gave you in the other video I had where I looked at the practice problems. We'll go through one more example of solving through substitution, and then we're going to go right into the word problems. Okay? So you most definitely should be looking at this video after you look at the video that has the solutions for the 8.2 practice problems, because we did a lot more of the simpler ones in that video. Anyways, we will begin. So if we take a look at number 1a here, and first of all, you'll notice that the direction is to solve each of the following systems. Remember, when we're solving a system, we're looking for that point where they intersect. Okay, the solution is that shared point that's common to both lines. So we know that at the very end of it all, our solution is simply going to be an ordered pair, right? Because that will be the point that they both share, the point where they cross. So, our first step, if we're going to solve by substitution, is to isolate one of our variables. And the easiest one to isolate is right here. It's the variable y. Okay? So, we're going to isolate this, and we'll isolate it by adding 9 to both sides. And that will give us 3x plus 9 equals y. Okay? So, our first equation ends up being y equals 3x plus 9. Now remember, at the point where we have our solution, at the point of intersection, we know that the value of this y will be exactly the same as the value of that y. Okay? That's the whole concept that we're trying to address here. Okay? So if we know that y equals 3x plus 9, that means it equals 3x plus 9 in this equation, and it equals 3x plus 9 in that equation. So we can go to this other equation, and we can rewrite it substituting our value of y wherever we see y. Okay, so it's just like when you have substituted a number for one of your variables. This time we're substituting an expression instead. So our expression is 3x plus 9, and that's what we substitute. And then equals 26. So you'll see I've taken this first equation and I've changed it by subbing in my value for y. What's so important about that? Well, it leaves us with an equation that has only one variable. And if you have an equation with only one variable, you can isolate that variable and actually find its value. So we're going to find what x equals. And so we simplify this side of the equation. Remember, you distribute the 5 over both terms inside. That gives us 4x. 5 times 3x is 15x. 5 times 9 is 45. Equals 26. Continue simplifying the left side. You've got like terms here that can be combined to give you 19x plus 45 equals 26. Now that we've simplified the left side, we isolate x. So we're going to get rid of this 45. We'll subtract 45 from both sides. 45 minus 45 is 0. That leaves us with 19x on this side. And on this side, we end up with 26 minus 45 is negative 19. Finally, get rid of this 19, divide both sides by 19, leaving you with 1x on this side and negative 1 on this side. So, we're halfway to our solution, okay? We know what the x component is now. It's negative 1. Now we have to find the y. And we can plug in this value for x into either of our equations. Now, I don't know about you, but I'm lazy. I would rather go with a simpler equation, so I'm going to pick this one. 3x equals y minus 9. So, into our 3x equals y minus 9, I'm going to plug my value for x, and it will become 3 times negative 1 equals y minus 9. Again, notice by doing this, we've created an equation that only has one variable, so we can isolate that variable. So simplify the left side. 3 times negative 1 is negative 3 equals y minus 9. And then isolate y. We add 9 to both sides, and we get 6 on this side. Minus 9 plus 9 is 0, leaving us with y. And looky, looky, we got our answer. Okay? So the solution is negative 1 and 6. And since we're only doing this one example, we'll verify it as well. Okay? Remember, when you're verifying, what you're doing is you're seeing, did I do it right? Okay? So you're going to take your solution. We're saying that at the point of intersection, the point is negative 1 and 6. Those are the coordinates of our point of intersection. So they should work in both equations. So let's see if they do. So for our first equation, 4x becomes 4 times negative 1. 5y becomes 5 times positive 6 equals 26. Simplify. 4 times negative 1 is negative 4. 5 times 6 is 30 equals 26. And negative 4 and 30 is 26. Left side equals right side. So it looks good, but we're not done. We have to also check this other equation. Okay? So we'll plug in our value for x and our value for y into the second equation, and we'll get 3 times negative 1 plus 6. Whoops. Sorry. 3 times negative 1 equals 6 minus 9. 3 times negative 1 is negative 3. 6 minus 9 is negative 3. Left side equals right side. We're done. Okay? So this is verifying it's done once you get your answer, just to make sure your answer is correct. So again, another really nice thing about these problems is you'll always know at the end whether you got the right answer, because it will always work. Okay? Let's move on, and we're going to take a look at solving some word problems. Now, solving word problems, if you follow the steps, if you kind of get into a routine where you always go through the same steps, it's very difficult to get these things wrong. Okay? Let's just see if we can get there we go. Okay, so our first question says, admission to an air show costs $80 for a car that has 2 adults and 3 children. Admission for a car with just 2 adults costs $50. Write a system of linear equations to model this scenario. So, as with all word problems, the first thing you need to do is make sure you have read and understood the problem. So, we will always have 2 variables, okay? We are going to create a system of equations. So you're going to have to create the 2 equations that you then solve, okay? And in order to do that, the first thing we want to do is we want to kind of declare what our variables are. We want to say, what are the things we're trying to figure out here? And in this case, the things we don't know are how much does it cost for an adult admission and how much does it cost for a child's admission? Those are our variables, okay? Now, most of the time, or much of the time, the word problem will actually tell you what the variables are. Usually it's located in the last sentence of the word problem. In this case, they haven't been quite so kind, but it's a simple problem. So we can set our variables. And what I'm going to say is, let the variable A equal the cost of an adult ticket. Okay, because we don't know that. That's one of our variables. The other thing we don't know is how much does a child's ticket cost. So that becomes our second variable. Let C equal the cost of a child's ticket. Now, do you have to use A and C? No. You can use X and Y or A and B or whatever. Sometimes it's helpful to use a letter that reminds you of what the value of that variable is, or at least of what that variable is describing, okay? So that's why I used A for adult and C for child. You do what you like, okay? So, now looking at the problem, we need to come up with 2 equations that are described in this problem. Well, let's start with the simpler one, okay? It says, admission for a car with 2 adults costs $50. So, we have 2 adults, and the cost for those 2 adults is $50, okay? So 2 times the cost of an adult ticket is $50. What about the other car? Well, the other car has 2 adults, but it's also got 3 children. So 2 adult tickets plus 3 children's tickets has a total cost of $80. Okay? Make sense? I hope so. So here are our 2 linear equations. Now it's asking us to solve that system. Okay? So, we take our simpler equation and we isolate a variable. That's our first step. So we're going to take this simpler equation, 2a equals 50, and we're going to isolate a. And this one's really easy because it only has one variable. We can isolate a simply by dividing both sides by 2. That will give us a equals 25. Whoa, look at that. We already have the value of one of our variables. So, here's the ordered pair that will describe our solution, and we know that A is 25. Okay? Once we have a value for A, we can substitute it into our second equation and solve for C. So, if A equals 25, our second equation becomes 2 times 25, right, the value for A, plus 3C equals 80. Simplify, 2 times 25 is 50, plus 3C equals 80. Isolate C. Do adding and subtracting first, so we're going to take away 50 from both sides. That will give us 3C equals 30. Divide through by 3 to isolate C. 3 divided by 3 is 1, giving us C equals 10. So what does that mean? That means if our variable C is the cost of a child's ticket, then a child's ticket is $10. Okay? Now, since this is a word problem, we always have to end it with a short statement answering the question. Okay? What does the solution represent? The cost for an adult is $25, and for a child is $10. Okay? So, that's what our solution represents. It represents the cost for an adult, the cost for a child. Now, some of you may be saying, hey, wait a minute, this isn't like XY, right? Because I have these two variables, what if I put my 25 as my second number and my 10 as my first? And the answer is, it doesn't matter, okay? So, if you put 25 and 10, or if you put 10 and 25, you'll be okay, okay? It'll be marked correct. Okay, this one's a little trickier, but I know you can do it. One of the nice things about this unit is you'll find, after doing a few of these word problems, you'll find that you get better and better at it, okay? So you begin to see, oh, this is one of those types of problems. For instance, the first one we were talking about item costs, right? The cost of a ticket. In this one, we're talking about dimensions. So I would strongly suggest that you draw diagrams for these sorts of problems, okay? That might help you a little bit, but let's read it. The perimeter of a standard tennis court is 70 meters. The width is 13 meters less than the length. What are the dimensions of the tennis court? So again, this is one of those ones, remember I told you, that sometimes they'll tell you what the variables are in the last sentence. And in this case they have, right? They've said you're looking for the dimensions of the tennis court. So, our dimensions, of course, are our length and our width. So we'll use L and W, right? Keep it straight. So, let L equal the length of the court and let W be the width of the court. Please be very specific when you're declaring your variables. Don't just write length and width, okay? Or in the last one, you wouldn't just say, let A equal adults, let C equal children, because it's unclear then whether you're talking about the number of adults or the cost for an adult ticket, okay? So be very specific when you declare those variables. Anyways, we're going to come up with two equations. Now, the first equation addresses the first sentence there. which says the perimeter of a standard tennis court is 70 meters. Well, you know this thing is a rectangle, right? Here's the length, here's the width, here's another length, here's another width. So, if you were looking for the perimeter, remember, the perimeter is simply 2 lengths plus 2 widths, okay? This gives you the structure or the framework for your first equation. Since we're talking about the perimeter and we're saying the perimeter is 70 meters, our first equation becomes 70 meters, the perimeter, equals 2L plus 2W. Hey, look at that. We already have our first equation. Okay? Now, the second equation, that comes from the second sentence. And this is very common in these sorts of problems. You're comparing the width and the length. Okay? You're saying, how is the length compared to the width? Well, what are they telling you here? They're telling you, first of all, ask yourself, which of these things is smaller? Okay? Now, it says the width is 13 meters less than the length. Now, when you're comparing these two things, you're going to put them on either side of the equation, right? Because we're comparing them. Now, what I've written here is length equals width, and we know that's not correct. How do we make it correct? Okay? What do we have to add to the width in order to make it equal to the length? Well, it says right up here. It says the width is 13 meters smaller or less than the length. So, in order to make the width equal the length, we simply have to add 13, right? Because this value is 13 less than this one. So to make it equal, we give it a little bit of help, we add 13 to it, and now it is equal to the length. Okay? So, the first one talks about the perimeter, the second one compares the actual size of length and width. And what's nice about this is we already have our variable isolated, right? Remember, that's the first step in solving by substitution. We want to isolate a variable in one of our equations, then we're going to take that expression and substitute it into our other equation, okay? So, if the length is W plus 13, then in this equation, it's also W plus 13. Remember, at that intersection point, the L's are the same and the W's are the same. So, we're going to take this expression, W plus 13, we're going to substitute it into our second equation to get 70 equals 2 times W plus 13 plus 2W. Okay? Now, again, the important thing is we have now created an equation with only one variable, right? There's no L there anymore. All we have is W, so we can isolate W and get an actual numerical answer. So, simplify the right side. 70 equals 2 times W is 2W. 2 times 13 is 26 plus 2W. Continue simplifying the right side. We have like terms that will combine. 4W plus 26. Okay, the right side is as simple as we can get it. Now we isolate the variable. Do adding and subtracting first. So we'll take 26 away from both sides. 26 minus 26 is 0. That leaves us with 4W. And 70 minus 26 is, what is 70 minus 26? 54. 54? 44. 44, yeah, 44. So 44 equals 4W. And then our last step, divide both sides by 4, giving us W on one side and 11 on the other. So again, we're halfway there, okay? Our width is 11 meters. Last step. Take your value for W for the width, substitute it into either one of these equations, and again, be lazy, use the simpler equation. So if our value for W is 11, we can take this equation, L equals W plus 13. We can sub our value for W in, L equals 11 plus 13, L equals 24. And we have our length. Okay? So we can verify this in our heads. Is 24 13 greater than 11? Right? Because we've said, remember, the width is 13 less than the length. Well, yeah, it is. If you add 13 to 11, you do get 24. Verify in here. Does 2 times 24 plus 2 times 11 equal 70? Well, 2 times 24 is 48. 2 times 11 is 22. And yeah, 48 plus 22 does equal 70. Okay? Finally, short concluding phrase. Length is 24 meters and the width is 11 meters. Okay? Done and done. Okay, let's do one more. This one is similar to the first one, but not exactly the same. So this one says, a movie theater charges $11 for an adult ticket and $8 for children's tickets. It's different from the one we just did previously because in that one we didn't know what the cost of the tickets was, okay? But we knew how many people were in each car. In this one it says, suppose 240 people attended the early movie and ticket sales totaled $2,370. How many adults and how many children attended the early movie? Again, notice the last sentence gives us our variables. It tells us what we're supposed to figure out. We're supposed to figure out how many adults and how many children. Not what the cost of the tickets were for adults or children. They told us that. Okay? So this time, we can use the same variables if we like, and we'll say, let A equal, but this time it's not the cost of an adult ticket, it's the number of adults. Let A equal the number of adults who attended. And then we're going to say, okay, let C equal the number of children who attended. So there's our variables. Now we go back to our problem, and it says, we don't know how many adults there were or children there were, but in total, we know that there were 240 people in the theater. So that allows us to come up with a simple equation, right? Where we know that the number of adults added to the number of children, so if we put them all together, we know that we have 240 people. So the number of adults plus the number of children equals 240 people. That's our easy equation. Okay? Our second equation has to do with the ticket receipts, the total amount of money taken in. Well, we can we can write an expression that describes that, because we know that an adult ticket costs $11, and we know that there were this many adults in attendance, so the total amount of money brought in by those adult tickets would simply be $11 per ticket times the number of adults. Similarly, for children, a children's ticket is $8. So it would be $8 per ticket times the number of children. Altogether, when you add up all that money that you took in, you get a total of $2,370. So, one equation talks about the total numbers, the second equation talks about the total amount of money taken in. Okay? So notice there will always be two different descriptions of the situation, and they're given to you in the word problem. Now, since we're solving by substitution, this is definitely the simpler equation. Let's isolate a variable, and it doesn't matter if you isolate C or A. I'm going to isolate A. I'm going to take away C from both sides, and that will give me A equals 240 minus C. Just get my calculator, because I think my brain may need some help in a minute. Okay, so we've rearranged to isolate A. Remember, the second step when we're solving by substitution is we're going to take this expression, because this is what we've said A equals, and we're going to substitute this expression into our second equation. Right? We know that if A equals 240 minus C in this equation, then A will also equal 240 minus C in our second equation. So we can sub that in, and instead of A, we're going to put 240 minus C, and then the rest stays the same. Plus 8C equals $2,370. And again, we've created an equation with only one variable. We can solve to find what C equals. So, simplify the left side. Distribute 11 times 240 would be 2640, I think. This is where he uses his calculator to check. 11 times 240. Yep. So 2640, 11 times minus C is minus 11C, plus 8C equals 2370. Okay. Like terms can be combined to give you 2640 minus 3C, right? Minus 11 plus 8 equals 2370. Now we've simplified the left as much as we can. Let's isolate C. So get rid of the stuff that involves adding and subtracting. Subtract 2640 from both sides. So that's 200 and, oh, my brain just exploded. 270. Yep. So on this side, we're left with negative 300. Oh my goodness. Oh my goodness. Negative 270. On this side, we have negative 3C. Complete the isolation by getting rid of the negative 3. So we're going to divide both sides by negative 3. Again, don't forget, it's a negative you're dividing by. Negative 3 divided by negative 3 will give us positive 1C. Negative 270 divided by negative 3 will give us a positive number. That makes sense, right? Because we're trying to find the number of children, you can't have a negative number of children. Okay? So, C equals 90, and into our solution, we'll plug in our first value. So we know there were 90 children's tickets sold. Okay? Okay, then how many adult tickets were sold? For that, we go back to our very first equation. A plus C equals 240, and we substitute the value for the number of children's tickets. So A plus, we now know what C equals. It equals 90, equals 240. Isolate A by subtracting 90 from both sides. 90 minus 90 is 0, leaving you with A. 240 minus 90 is 150. So that means we have a solution. Okay? So, finish it up with a short statement. There 150 adults and 90 children at the movie. And that brings us to the end of today's lesson. Have a great day. We will take a look at a different method for solving a system of equations in the next lesson. I bet you can't wait.